Hello everybody, this is Mr. Ainsworth, and we're going to get into yet another review, final review 2 for Algebra 1 here in second semester. Getting ready for the end of the year, man, your final. And there's a lot to cover because it is a yearly final and it covers both semesters, but concentrating on semester 2. So I picked a few problems that are going to be on the exam, the types. So you got to know the techniques that are illustrated in here. So, excuse me, check your work, and if you need to, use your notes. Make notes on the side in red, so get out a red pen and put the key points in red and know your strengths and weaknesses, okay? And go at your pace. All right, so what we want to do here first is factor the third-degree polynomial, and we want to use factor by grouping. So factor by grouping, which we've been doing for the last 3 months. Okay, all right, so this is, I think it was Unit 5. So Unit 5. Okay, so we have two groups. First group, second group, and we want to factor out the GCF. Factor out, all right, GCF. Factor by grouping, so here we go. So the GCF of 15x cubed and 40x squared is 5x squared, okay? Both 5 divides into 15 and 40, and you always take a look at the lowest exponent here, comparing x squared and x cubed, it's the lowest exponent. So we're going to factor out at 5x squared. So 5x squared times 3x will give you the 15x cubed. Then 5x times 8 will give you the 40x squared. Distribute through to check your work. And both 9 and 24 are divisible by 3. And they don't contain variable. This 24 doesn't contain a variable, so the only GCF of 9x and 24 is 3. So I'm going to factor out a positive 3, so make sure you put a plus sign there. So 3 times 3x is 9x, and 3 times negative 8 is obviously negative 24. And notice that the binomials are the same, so, and they have to be. So step 2 would be to factor out the common binomial, which is now the new GCF, right? It's a common binomial. And the remaining factor, all right, is right here, the 5x squared plus 3. So you want to multiply that by 5x squared plus 3, and it's called factor by grouping. We did that like 2 or 3 months ago. And we've been using it in Unit 6 in quadratics, and we've been using it in Unit 7 on quadratic functions. So we've been using it for the last 3 months. So this technique will definitely be on the test. In fact, it's involved in number 2 as well. So let's play the factor game here. So here we go. So what two numbers multiply right here? 5 times negative 5 is negative 25. So what two numbers multiply to negative 5, all right, and add to 24? All right, and so the factor pairs of 25 are simple. They're 1 times 25 and 5 times 5. 5 and 5 is 10, which do not add up to 24, so these factors cannot be used. So we're going to have to use the factors of 1 and 25 to make 24. So to get a negative 25, and we want to get a positive 24, so I'm going to make the 1 negative. So negative 1 times 25 is negative 25. Negative 1 plus 25 is 24. So this is equal to 5x squared, all right, plus 25x. I'm going to split the middle term, minus 1x minus 5. All right, I split the middle term like I've been doing, okay, for the past 3 months. All right, now we do the factor by grouping. So out of the first group is 5x. Factor out of 5x, and we get 5x times x is 5x squared. 5x times 5 is 25x. In the second group here, they're both negative, so factor out a negative 1, and you're going to get x plus 5. Distribute back and through and check. And remember that these binomials have to be the same in the factor by grouping technique, okay? Otherwise, it's not factorable. So that last result is x plus 5, your common binomial. Let's highlight that. That's the common binomial multiplied by the remaining factors, which is in this case is 5x minus 1. So we get 5x minus 1 here. So yeah, there's going to be factoring on the test, and you got to get good because you know that is the main concept in semester 2. All right, factoring. There's a lot of factoring involved. Okay. Now, when you square a binomial, you go back to basics. All right, 7x minus 2 squared is 7x minus 2 times 7x minus 2, right? And then you use the FOIL technique or distributive property. All right, so here we go. So 7x times 7x is 49x squared. 7x times negative 2 is negative 14x. Negative 2 times 7x is negative 14x. And negative 2 times negative 2 is a positive 4. So the end result here is 49x squared minus 28x plus 4. All right, you square, you multiply by itself. This is how you square a binomial. Square a binomial. This will be on the test too. All right, all these concepts will be, all these techniques are concepts. Okay, number 4. What's the range? Ooh, okay, the range. Set of y values. This is unit 7. Okay, so you have your notes in unit 7. So you want to do is you want to look at the vertex. All right, look at vertex. So let's do that. So this vertex right here is 1, 4. So let's write that down, 1, 4. And the y value is 4. This is a max. All right, and if you look at the max y value, it doesn't get any higher than 4. So the range is y is less than or equal to 4. It's that simple. Okay, this one's a little bit different. This is a minimum, and the vertex is 2, negative 1. All right, it's a min. All right, it's the lowest point. You can see the lowest point right here is negative 1. This is y minimum. All right, the y minimum is negative 1. So all the y values on the parabola, since it lies above it, are greater than or equal to that negative 1. Okay, so the range depends on the vertex. The range depends on the vertex. Range depends on the vertex. And if you look at your notes in unit 7, we wrote that down every single time. Well, at least every single time I worked with you. Okay, it always depends on the vertex. You've got to find that first. Look at the y value. So let's highlight the y values. Okay, they're right there. And you use that y value. Okay. Now this these exponential functions here. Now this goes back into like unit, I don't know what it was. It was a previous unit in the beginning of the second semester. And you have your exponential function unit, so you should find your notes. Okay, we did all the work in there, so find your notes. All right, on exponential functions. We talked about the horizontal asymptote, which I called, HA in our notes, horizontal asymptote. And it's a imaginary line that the function approaches but never touches. And you can tell that this right here, this horizontal asymptote, is at y equals 2. So it's a horizontal line at y equals 2. The function gets closer to that but never crosses it, never touches that. And the range depends on the horizontal asymptote. And the range, which is just a set of y values, since they lie above, okay, above this value of 2, all right? So the range is greater than 2, not greater than or equal to. Okay, common mistake. All right, is that people think that the range is greater than or equal to 2, okay? This is incorrect. All right, because I said the graph never touches y equals 2. The function can never assume the value of 2. All right, it's impossible. Now, not only that, look at the function right here. Notice the shift right here. All right, this is the vertical shift that I was talking about in your lesson. If you look at your notes, all right, it's an upshift of 2. And just by looking at this function right here, you can tell first of all that you have a horizontal asymptote at 2. So this can just give you a real clue right here if I just give you the function and not the graph. And then it also, since it lies above, this is positive right here. All right, 4 is positive. It goes up. It's a growth function. And then also this is the base right here. The base is 2. Base equals 2. It's a growth function. And you guys need to know that. And since it's a growth function, it goes up, all right? Upward, exponentially. It grows upward. That's why we call it a growth function, right? It grows upward right here. And because of that, the y values are always greater than 2, all right? So they're all interconnected here. You can look at the base, determine if it's growth. You can look at the shift factor, which in this case is +2, right? +2, to determine the horizontal asymptote and the range, even without the graph. Like right here, I'm looking at this right here. This is the downshift. Okay, so downshift of 1. And so automatically, I know that the the horizontal asymptote is at -1. Okay, that tells me that the horizontal asymptote y is at -1. Let's draw it in. Okay, it's right here. Okay, so y equals -1. That's my donkey, by the way, in the background. Okay, and since it's a growth function right here, the base is 2. Base is 2. That tells me it's growth. Alright, and it goes upward and it tells me that the y values are greater than -1. Okay? So the range lies above the horizontal asymptote. That's what I'm saying. So there's a lot of things. You don't even need the function, the graph, in order to determine these things. Okay, you do not need the graph to determine this. And by the way, that probably is a test question, so I just illustrate that. Okay? So know your basics. Alright, and that's number 5. Number 6. Okay, what are the exact x-intercepts? And what is the function? Okay, so let's figure out the vertex first. These are, okay, so we can identify this is at 1, 4. Okay, this is h and this is k. And y is equal to a times x minus h, quantity squared, plus k. This is called vertex form. So, and we have to determine the a value. All right, so we go right 1 and then down 1 right here. And then right 2, down 4 right here. Down 4. So if it's down 4 and down 1, right there, I know a is 1, or excuse me, -1, because it goes down, so it opens down. So it's negative, so it opens down, so it's negative. And since we go right 1, down 1, as opposed to going up 1, I know a is -1. So I know the function y is equal to -1 times x, all right, minus 1 squared, all right, plus 4. All right, what are the x-intercepts? Well, let me see right here, a and b. So a at -1, 0. Okay, b, that's at 3, 0. Now this one's a little bit different. This goes up instead of down. And right here, the vertex is at 2, -1. And from point to point, I got to go right 1, up 2. All right, up 2. So I know a is 2. Positive 2. All right, because it goes up. So I know my function now. So y is equal to 2 times x minus 2 squared minus 1. All right. And my the x-intercepts, kind of hard to find because I don't know what they are, so I got to solve this. Okay, so I'm going to do this one over here. Okay, so find x-intercepts. So this is for the second one, so set y equal to 0. Okay, so here we go, 0 equals 2 times x minus 2 squared minus 1. Go ahead and add 1. So 1 is equal to 2 times x minus 2 squared. Divide by 2. And I get 1/2 equals x minus 2 squared. Now square root. So I get, at this point, I get plus or minus 1/2, excuse me, square root of 1/2. All right, is equal to x minus 2. And then I'm done at 2. So I have to add 2. So I get 2 plus or minus the square root of 1/2. Okay, so my x-intercepts at A right here. This is point A. So 2 minus the square root of 1/2, 0. At point B, it's 2 plus the square root of 1/2, 0. And there's B right there. Okay? The one on the right is addition, the one on the left is subtraction. You can check that with a calculator if you want. Although there's no calculator allowed on the test, so you're going to have to do this without it. Okay, so find x-intercepts here. Actually, let's find the function first because we can't do that. So here we go, vertex, -3, 3. So vertex, -3, 3. And A is -2. Now I go right 1, down 2. So A is -2 because it opens down. So this function y equals -2 times x plus 3 quantity squared plus 3. And I don't know what the x-intercepts are until I solve for them. So 0 equals negative 2 times x plus 3 squared minus 3, or plus 3. So subtract 3, and you get negative 3 squared. Excuse me, negative 3 is equal to negative 2 times x plus 3 squared. That's what I meant to say. Divide by negative 2 because you got to isolate. So you get 3 halves is equal to x plus 3 squared. Now you square root, just like the other one over here. Okay. Don't worry about it if you have fractions, just go with the flow. So you get plus or minus the square root of 3 halves is equal to x plus 3. And then when you subtract 3, you're done. So you get negative 3 plus or minus the square root of 3 halves. Okay, so here we go. So the first x-intercept, A, is at, let me see, negative 3 minus the square root of 3 halves. Negative 3 minus the square root of 3 halves, comma 0. B is negative 3 plus the square root of 3 halves, comma 0. All right, no calc on the test. All right, you have to do this all by hand. So no calculator. All right, on final, you have to know what you're doing. All right, you have to be able to do this by hand. Okay, okay. All right, let's move on to semester 1. We did this in semester 1. Like I said, it's a yearly final. Okay, so what's a slope? All right. So slope is rise over run, as you guys should know. It's one of those basic concepts. So from A to B, all right, the slope is simply down 3. And that's the rise with no run, 0 run. So 0 run. So rise over run. So in this case, it's negative 3, or 0 divided by, excuse me, what did I, the rise is negative 3. Yeah, I said it right. Okay, so negative 3 divided by 0, and this is undefined, okay? Undefined, all right, so which means there's no slope here. Okay, next one, from A to B, all right? You go right 3, there's a run. So it's going to be, and 0 rise, by the way, 0 rise, all right? So it's going to be 0 divided by 3, which is 0. Okay, it's horizontal. Horizontal lines always have a slope of 0. On this one, from A to B, you go up 2, right 2. So up 2, right 2. So 2 divided by 2 is 1. This is the positive slope direction. This is a negative slope direction. So from A to B over here, you go right 1, 2, 3, 4, 5. So you go right 5. All right, down 1. So negative 1 divided by 5 is negative 1/5. Okay? So positive always goes to the upper right. All right? Negative slope always goes to the lower right. Okay? Easy way to identify them. And then horizontal is always 0. Okay? Horizontal lines, always 0 slope. Okay. Piece of cake. That's semester 1. All right, semester 1 again. What's the y-intercept? Okay, the point where it crosses the y-axis, right? So point or value, point where it crosses, crosses y-axis. That's why they call it a y-intercept. So right here, okay, the y-intercept is 3, or 0, 3. All right, the b value is 0, 3. That's 0, 3 right here. Write it in order pair form right there. This is called the y-axis. Down here is called the x-axis. Here the y-axis is vertical. There we go. There's your y-intercept at 0, -2. All right, 0, -2. Once again, this is semester 1. Linear stuff. Okay, this is the exponential function unit. You guys have your notes. So see your notes in there because we did a lot of these things, okay? So take out your notes. You should always keep your notes until the end of the year. In fact, you should keep all your Algebra 1 stuff because in Algebra 2, 2 years from now, you know, after geometry next year, you're going to have to remember all of this good luck. Okay, so keep your notes. Okay, so here we go. We apply the negative first, right here. The negative exponent reciprocates the fraction. Reciprocates, all right, the base. All right, so you take the reciprocal 1/2 and you get 2. Okay, if you look at your notes, I said that. So you reciprocate first. All right, and then you evaluate. So you get 4. So the reciprocal 1/5 is 5, and then you got to cube it. All right, 5 cubed is equal to 5 times 5 times 5, and that's 25 times 5, or 125. All right, always do your side work. And this doesn't have a negative exponent, so it's 1 cubed, which is 1, divided by 3 cubed, so the answer is 1/27th. Okay, only terms with a negative exponent get reciprocated. For example, like 2 to the negative 7th power, it's the same thing as 1/2 to the 7th power, and this is equal to 1 to the 7th, which is 1, divided by 2 to the 7th, and then you got to do your base 2 again. So 2, 4, 8, 16, 32, 64, to the 1st, to the 2nd, to the 3rd, to the 4th, to the 5th, to the 6th, and then 2 to the 7th, which is 128. So this is equal to 1 divided by 128. So what you do, that's one way to think about it. Okay, or you can just convert it to a fraction. So this can be written as 1/3 squared, which is 1/9 to the 8th. If this is 2 to the 7th, then 2 to the 8th is 2 times as big, so this is 256. And then 4 cubed is equal to 4 times 4 times 4, which is 16 times 4, or 64. All right, so this is 64. So you have to know your base 2, 3, 4, and 5. All right, so let's write that down. So know, all right, your powers. Okay, up to 3, 4, 5, and 6. All right, they're all in your notes, by the way. Okay, going back to semester 1 again. So semester 1, find the slope. So that's going to y2 minus y1 divided by x2 minus x1. So if you want, you can line up the points vertically. So -3, 8, all right, and 3, 2, all right, and then you subtract up. Okay, so 2 minus 8. So 2 minus 8 divided by 3 minus a -3. So 3 minus, not 3, but 3 minus a -3. And this gives you a -6 divided by 6, or a -1. Okay, so you have to know your basic definitions. Okay, f of -3, you got to evaluate it. So this is, you need to substitute it in where you see the value of x. So it's the exponent. So it's 3 times 1/3 to the -3 power. Okay, so like I said earlier here, you got to reciprocate the fraction. So this is 3 times 3 cubed. All right, you reciprocate first. All right, which is equal to 3 times 27. All right, so 3 cubed is 27, right? 3 to the 3rd power is 27. And with the final result, all right, 60 and 21 is 81. So this is 81. Again, this is unit 7, or unit, I don't know, this is the exponential unit. So again, refer to your notes, okay? All right, state the domain, the set of all possible x values. So again, this is semester 1. All right, so the domain, what you have to know there, is the set of all possible x values. Set of all the x values. So in the domain, I see -3, 1, 6, and -1. So -3, whoops, -3, comma 1, comma 6, comma -1. It's a set of x values. Okay, it's that simple. All right, 14. Find the value of a. Okay, so y is equal to a times x minus h squared plus k. These are all in vertex form. Okay, so let's identify. So this is a right here, and this is h, and this is k. So a here is -3, vertex at 4, 7. Okay, a equals -3. That tells me that it opens down. Because the vertex, because it opens down, we have a max. So this refers to a max. Okay, and the max y value is 7 in this case. All right, and so the range y values are less than or equal to 7 because it is a max y value. Okay, because it opens down. All of 3 of these parabolas open down because they have negative lead coefficients. So for example, in the next one here, a is -1, and h is 5, and k is 10. So it's 5, 10. All right, it's a max because it opens down, and the max y value is 10. So the range is y is less than or equal to 10. So if you know what the a value is, this tells you if it's negative, it opens down. Okay, if that's the case, you always have a max at that vertex. And in this case, all right, the h value is -1, 0. So -1, 0. And in this case, y value, the max y value is 0. So the range is y is less than or equal to 0. Okay, the range depends on your vertex. Range depends on the vertex. So you have to identify that first. And if you look at your notes, we wrote that down. In fact, I reviewed that earlier. Okay, now the opposite of that is a parabola that opens up. So in this case, a is 2. All right, this one opens up because it's positive. All right, at 1, 4. So h is 1, k is -4. So at 1, -4, it's a minimum now, and the minimum y value is -4. So the range has got to be greater than or equal to the -4. It depends on the vertex. So if this one opens up, the range has got to be greater than or equal to the minimum y value. And the second one, a is 4. The vertex is -6 now, -2. -6, -2. Then minimum y value is -2. So the range is greater than or equal to -2. And in this case, a is 1, still opens up. Okay, opens upward. So the vertex is -1, -5. -5 right here. It's a minimum y value is -5, so the range is greater than or equal to the -5. These are all basics, and this is all Unit 7. Okay, you can take out your notes and review that because I did go over all this material. Okay, now going back to your exponential function. So get your other yellow notebook labeled exponential functions. Okay, the general function for all exponential functions in general form. Well, it's not the full general form, but this is the basic one right here without any shifts. Okay. The other one we studied was y is equal to a times b to the x plus k. The other one was y equals a times b to the x minus h, because we talked about shifts. This was a vertical shift, and this is a horizontal shift. And if you look in your lessons there in that unit, you'll see that we talked about those in the different lessons here. But let's go over some basics here. Key concept. All right, growth. All right, the base is greater than 1. All right, so you have to identify the base. All right, and decay, the base is between 0 and 1. It's a fraction. All right, so something like 1/2 or 1/3, let's say, or 3/4, let's say, anything between 0 and 1. Okay, so now we want to identify the base. So let's highlight the base. All right, so there's your base. The base is 2. All right, base equals 2, so that tells me that it's a growth function. Okay, why? Because it's greater than 1. Right, 2 is obviously greater than 1. Okay, next function, base is 1/2. So the base is 1/2. All right, that tells me that you have a decay function, right? Because the base is between 0 and 1. 1/2 is between 0 and 1. Okay, next function right here, base is 3. Just giving you some experience here. That tells me you have a growth function because obviously 3 is greater than 1. Okay, you have to go back and know your basics. All right. And this one right here, this is a polynomial function. This is not exponential. let's write down not exponential. So you don't even respond, okay? This is a quadratic function. Quadratic function, all right, degree 2. All right, and this one here too, this is y equals 4x minus 5. This is linear, y equals mx plus b. This is not exponential. So we don't even answer the question up here. Okay, we don't say whether it's growth or decay because you only respond to that if it's exponential, right? Right. So it's not exponential, it's linear. All right, degree 1. All right, degree equals 1. All right, first degree, second degree. So again, you're going to have to identify functions. You're going to have to know when it's linear, quadratic, exponential, because guess what? We studied them all this year. Okay. Next concept, rate of change. All right, key concept here. So we want to figure out, what in the world is the rate of change? Because you're going to have to know if the, what the rate of change is and answers, different questions. So for example, on this one right here, we'll call this one example A, and this one B, okay, and this one C. We want to do 3 things. Number 1, we want to evaluate the function at the given points. Number 2, we want to find the rate of change. 3, we want to determine if the rate of change is constant or not, and then state your results. Okay, so we got 3 things to do. So let's evaluate first, and let's go back to basics. All right, so here we go. So y is equal to 2 times x. So you got to substitute x in. That's how you evaluate any function, right? So 2 times negative 3 plus 1. Well, that's negative 6 plus 1, or negative 5. 2 times negative 1 plus 1 is negative 2 plus 1, or negative 1. 2 times 1 plus 1 is equal to 2 plus 1, which is 3. And then 2 times 3 plus 1 is 6 plus 1, or 7. So when you find the rate of change, you find the rate of change of the x values first. All right, from negative 3 to negative 1 is a change of 2. From negative 1 is a change of 2. From 1 to 3 is a change of 2. I called this delta x back in the day. From negative 5 to negative 1 is a plus 4. From negative 1 to 3 is a plus 4. From 3 to 7 is a plus 4. And back in the day when we taught this, or when I taught this, I called this the change in y, or delta y. This is the change in y. So my rate of change, okay, rate of change is equal to delta y divided by delta x. Okay, rate of change. And so that is equal to 4 divided by 2. 4 divided by 2, which is 2. And it's constant for every set of 2-order pairs. So looking at the first results here, 4 divided by 2. I take 4 and divided by, again, delta y divided by delta x, divided by 2. 4 divided by 2. 4 divided by 2. So in each case, the rate of change is 4 divided by 2, or 2, so it's constant. Okay? And it is because this is a linear function. Okay? So the rate of change is constant. And we know it's linear because of that. And it goes the other way too. Linear functions are constant, rate of change is constant all the time. Because the rate of change is the slope. I mean, because it's a line, okay? Linear functions are lines, and only lines have a constant rate of change. In fact, let's write that down, okay? Only linear functions, okay, which are lines, okay? Lines, straight lines, by the way. Only linear functions have a constant rate of change. That's what makes them lines, people. Okay? They're straight. If they don't have a constant rate of change, they become curves. Okay? Exponential curves, or quadratic curves, or cubic curves, as you're going to find out throughout the years when you guys study mathematics. Okay, next one here. Let's take a look at this one here. We have a quadratic. We have degree 2. So this is a quadratic function. All right, degree 2. So here we go. Let's analyze it. So we got to substitute negative 1 in. So negative 1 squared plus 1 is 1 plus 1, or 2. All right, 2 squared plus 1 is 4 plus 1, or 5. All right, 5 squared plus 1 is 25 plus 1, or 26. 8 squared plus 1 is 64 plus 1, or 65. So when you analyze the rate of change, okay, let's figure out delta x first. All right, from -1 to 2 is a plus 3. From 2 to 5 is a 3. From 5 to 8 is plus 3. All right, so delta x is constant. Here, this is a plus 3. Delta y is first is plus 3. And then plus 21. Oh, delta y is not constant. And then right here, delta y from 26 to 65 is probably 35. So 35, so plus 35. So notice that this is not constant. So my rate of change here is 3 divided by 3, which is 1. Here, my rate of change is 21 divided by 3, all right, which is 7. All right, and here my rate of change is equal to 35 divided by 3. All right, so right here, not constant. Okay, it's not constant. Why? Because it's nonlinear. As I said earlier, only linear functions, all right, have a constant rate of change, and this is not linear, it's degree 2. It's called a quadratic. Okay, and when you analyze the rate of change, what you're going to have to do on the test, because I'm going to give you a table to analyze, all right, you're going to have to look at the rate of change between each pair of points. You have to analyze, all right, the rate of change, all right, between each pair of points. A lot of common mistake that people make is they only do it once, and then they don't analyze the rate of change between each pair of points, and they make improper conclusions. So make sure you do that. Okay. All right. Next one here. Let's analyze. This is exponential now. This is an exponential function. Why? Because the variable x is in the exponent, right? Okay. So it's not in the base, it's in the exponent. So let's evaluate this. So 2 to the -1 power plus 1 equals 1/2 plus 1, or 1.5. Next one, 2 to the 0 power plus 1 is 1 plus 1, or 2. And this is 2 to the first power plus 1. 2 plus 1 is usually 3. And then 2 squared plus 1 is 4 plus 1, or 5. Okay, so let's analyze the rate of change. So here it's plus 1, here it's plus 1, and here it's plus 1. So delta x is constant, but is delta y? I don't know. From 1.5 to 2 is a plus 1/2. From 2 to 3 is plus 1. From 3 to 5 it's plus 2. So delta y is not constant. So here, what this tells me is that the rate of change is 1/2 divided by 1, which is obviously 1/2. Here, the rate of change is 1 divided by 1, or 1. And then here, the rate of change is 2 divided by 1, or 2. So because of this right here, rate of change is not constant either. Okay? And again, this is a skill that you're going to have on the test, because I'm going to give you a table and not the function, and you guys are going to have to analyze the rate of change. All right? The rate of change is not constant. Why? It's because it's an exponential function. And only linear functions, as I said up here, only linear functions, which are lines, have the constant rate of change. So if it's exponential or quadratic or cubic, it doesn't really matter. If it's anything but linear, okay, it's not, the rate of change is not constant. Okay, key concepts on the test. Okay. All right, and I think that's it on the first one here. So this is a video, right? So you can always rewind and go back through it and go at your own pace. And this is the second of different reviews to get you ready for your final. So do your best, analyze your strengths and weaknesses, and practice, study. Do the right thing, all right, because you're going to need to. Finals are not easy at all. So do your best, and I'll see you in my next one. All right, bye-bye.